lot about the hackathon. Just to give you guys a sense of what's actually there. What we've done is we've taken these DICOMweb APIs from 3 of our API suppliers, Agfa, McKesson, and Vital, and we've spun these up in the Amazon Web Services. So these are in the cloud, so they're accessible not only here, but also from everywhere else. And there's an authorization you have to get access to them. We've taken EWIT's open source EWIT's implementation of FHIR, put that up there. So we have the clinical data, we have the imaging data. We've also put up, if you've been following SIIM's initiative in SWIM, that API is spun up. We've also got links to a number of different APIs that are out on the internet. So there are ones for radiology report templates, so you could take some data from FHIR, go and see prior imaging, and then learn about what imaging was done, and then go and do a query and discover the most appropriate reporting template, bring that down, and show all of that in one web page. There's also some radiology gametes ontology. We've got an access to a company called Human API has given us access for the duration of the hackathon, which allows us to go in there and mash up with information from like mobile portable glucose monitors, iPhone type apps, where they basically normalize all that down to a REST API. And we've got all of the documentation and all the forums and help stuff in a forum running on Liferay, which is a social media platform. So that's where the actual registrants will pose questions and we'll support them. So our intent with this is hopefully not to go beyond just the annual meeting, and over the years, we've committed to this for a number of years at the board level, to develop actually a playground where SIIM members can come in and actually try and learn how to use these type of things before they actually have to go out and buy one and then have it show up on the doorstep and then say, well, what does it actually do type of thing. So we don't just want to talk about it, we want to give you the ability to do that. So how do you find the hackathon? You're going to go out this door, you're going to hang a right, and it's on this level, just down a few meters there. On Friday at 2:45 to 3:45, we're having something called our Code Hero Challenge. So we've got 3 extremely experienced software developers, integrators, healthcare standard designers, R&D managers. They're all going to be there, and they're going to have a whiteboard in front of them, and you guys are going to bring your hard problems, and they're going to tell you how using FHIR and how using DICOMweb they would actually build that app, and they're going to draw it out. So you're going to actually see, when you always say, well, why is it so hard? Why can't my vendor do this? Why can't software developers do that? You're going to see some of the best and brightest real time. So think Iron Chef meets healthcare IT. They don't know what problem you're going to bring, and but I have high confidence. And there was one thing I did want to mention is I want to really, a lot of these sessions we talk about, we throw up the sponsor's name, but I want to really give a shout out to all these people listed here. This isn't just a bunch of people who wrote a check. This is a number of corporate leadership, people who've really been good friends of SIIM, who put enormous amount of their employees' time. You're talking about developers working nights and weekends, spinning up these servers, joining calls every week, putting in sample data, building the forum, documenting the APIs. And remember, some of these web APIs, the DICOMweb stuff, I mean, this stuff was only signed off at like later half of 2013. They did not have years to prepare for this. They jumped in with both feet, and I think that they've done an enormously good job, and they could never have done this. We could never have put this on without them really going above and beyond all the work they did there. So I think it's a great example of what SIIM is all about, that collaboration. And we're doing it all for your education so that you can actually try this stuff and learn in a safe environment among friends. Hi, I'm Don, and we're just wrapping up our 3rd day of the SIIM's inaugural hackathon, where we're going to hear about all kinds of great apps that have been developed on the Keto standard, or DICOMweb standards, and the HL7 FHIR. And after 3 days of sweat equity, minimal profanity, and no violence, we've come up with some amazing things, so enjoy!
We took an off-the-shelf legacy, meaning current, DICOM query retrieve application, and we pointed it at our query spanning service, which is going to query our archive, which is some test data in it. And we're going to merge in data that is coming from the McKesson archive, which we're accessing via the new DICOMweb Keto. So here is your typical workstation viewer, just running on Windows. And see, there are a list of studies, 3 of which are coming from our archive, and 3 of which are coming from McKesson.
So that's an example. That's great. there's an example where you have a PAX type client or workstation type client. You may have a local system, and you want to know everything for that patient that's locally, but you also want to check against the regional HIE, and you don't have a connected LAN or VPN to them, so you want to go over HTTPS, use the context that you know locally, collect that as a complete patient longitudinal record and present, even though that's not all in one system, not all in one database. And that's the power that this REST-based APIs allows you to traverse these things, and not just patient record data. As we heard about HL7 FHIR, it can also be problemless. It can be anything.
Yeah, and I think exposing an HTTPS endpoint to the internet is going to be a much easier sell than exposing raw DICOM or even secure DICOM.
Yeah, and the configuration management and everything is so much easier. So thanks a lot for sharing that, guys.
Yep.
Who wanted to go next? Do you guys have something to demo? Do you want to show something? Sure. You ready? Or do you want me to pick somebody else first?
Either way, Jim's in the session. I think he was just presenting.
Okay.
So maybe if I go a little later, might be able to.
What's that? The guys from Vital, do you guys want to go? All right. This is how hackathons work. Point a finger and people start plugging in computers.
So I'm Dave Reich from Vital, and what we came here to do was to see if we could hook into the WATO-RS standards that Agfa and McKesson are exposing on their archives, and also to use their Keto to see if we could get a list of patients. Because one thing that we've got that would be very interested to hook up to that is our universal viewer, Vitria View. And we wanted to see if we could change it to read the WATO standards instead of what it's reading today. And so what I'll show quick here is to log in through standard stuff is a very quick web application that we put together, and this is making calls to the Keto endpoints on both the McKesson and the Agfa services. And you can see that it's actually returning all of the studies that are out there, or at least the ones that we know about. And this was done very quickly using the open web standards. We're making calls through JavaScript, and so this is just a plain Jane web app. Quickly getting some information and displaying it on screen. And we could have put a lot more information on here to make it more interesting, but we put up enough to be dangerous. And then what we can show is the other side of this is if we click on one of these, it'll actually launch into our viewer, and it'll start showing, pulling the images down through the WATO-RS directly. And this is 99% of our existing viewer code. The only difference is that we connected the WATO-RS web standards instead of using another web standard that we developed against. And so as you can see, we're pulling in images that are real for this happens to be on the McKesson. And we can also open up other ones. Now it's a bit slow, so it's probably because these are running on VMs out in the cloud, and we've got slowish Wi-Fi in the house here. And there's definitely going to be a lot of work in the future where everyone will optimize it to try and get images and the metadata down as fast as they can. So that's what we were able to achieve. And really only took a few days of effort. The work list itself took a few hours, and then making our existing code work with the web standards, that took a few extra days, but at the hackathon it was great to connect with McKesson and with Agfa and find the little quirks that haven't been fully worked out of the standard, and we can get things done.
So that the query list page, that's something you built for the hackathon. So that's an example of new code. And then what you're showing in the Vitria view is an example of an existing commercial product and how quickly you're able to adapt it to use the new standards, because everything above getting the data still is the same. It's about the protocol and retrieval.
Right, exactly. So yeah, it's an existing product out there, and it was using a different web standard, but looking back at the development time, we were stressed over the last month with releases and things, so we really only had about 4 days of development, and this is what we're able to achieve.
Great.
So it's not bad.
Thanks.
Just one more comment while you're switching laptops. It may seem like that was slow for the image to come down, but if you think about the difference between calling another hospital and asking to send a CD, that's like light speed.
Right.
Yeah, and again,
That's true.
just to reinforce what that was, this is an existing application with a couple of days of effort, querying 2 cloud-based repositories, coming up with a common list, and then actually being able to retrieve that data and visualize it, which that could be embedded in the EHR, embedded in the PHR, embedded in the HIE, and that's all going securely over the internet
Right, exactly.
with a few days of effort. And that's the power of these REST-based APIs, is taking all of the power of the existing stuff we've invested in, DICOM, information model, archives, modality, communication, all of that stuff, not throwing any of it away, not having to convert any of that data or transform it, just building on discovery and accessibility protocols on top of that, and unlocking all of this web power. So I think it's a fantastic demo of that. I appreciate you sharing that.
Sure, thank you.
We have another group that wants to come up next.
So I'm Jim Morrison. This is Jason Hostetter. We're from the University of Maryland. Jason's a resident. I'm a fellow currently in radiology. And we put together a web app ourselves basically over a day. We started about 9 o'clock yesterday morning and worked till about 2 a.m. and tweaked it a little bit this morning. So there's a few APIs that we used. One is called FHIR. So there's a cloud-based repository of patient information and patient reports. There's something called gamuts, which allows you to input some type of pathology, and it will give you things like may be caused by or may cause. And then another API for BioPortal, which allows you to interact with RadLex. So if you don't know what RadLex is, it's a lexicon of radiology terminology. So we kind of combine those 3 things with the idea being, can we grab a radiology report from this cloud-based archive, and then can we input that radiology report text and into gamuts and see if it will pick out the interesting words and put this all together in a kind of a differential diagnosis. Jason will demonstrate here.
Yeah, so essentially we had an interface on the left where there's a text box you can put in, just copy and paste or type in report text. And we also hooked up to the FHIR test database that they have available here. And for us, this was a new thing that we were playing around with. So it's a very simple just query for existing radiology reports. And there was only 1 or 2 in the test data, so we created a few extra as well. They look like this. And so if we can load that text in and then send it off. And what's this doing is first sending that text to the BioPortal annotator API. And that API tries to find any relevant clinical terms that are existing in RadLex and bring them back to us. And then we send those terms to gamuts and check and see if they exist in their database and then what the associated pathology potentially would be with that. And so we try to, we find that associated pathology and get a huge list of terms, which we then rank order based on frequency of occurrence to try and generate a somewhat reasonable differential diagnosis for something that might represent what the report is talking about. So obviously this is a kind of just a fun idea, proof of concept. There's a lot that could be tweaked or optimized to maybe make this more accurate, but we did find that with some very well-chosen words in our example data that we could describe some hepatic findings and get a list that shows some hepatic pathology at the top of the list. So we thought this was just kind of a fun example of how you can mash up a lot of APIs out there that provide a lot of really good knowledge into something that might be useful.
So just to remind everybody that the FHIR API is actually driven by the standards group HL7. So it's really focused on clinical data, where the DICOMweb stuff is shown on really on the medical imaging information. So the first view we saw was really more exploiting the DICOMweb standards, and this one traversed not only the FHIR standards, which would be a way of accessing the clinical data for given patients, but also going out to general APIs that can use that information from a particular patient record and get information in context just by doing lookups against directories of structured reports or gametes or other things. So that's how quickly you can mash up these new apps using these new APIs that the standards groups are putting together. So Chris is going to do a demo.
So, hi, my name is Chris Hafey. I'm with Lury, a company focused on building web-based medical imaging applications. I actually have two things to show today. First is a work list. This is using the Keto RS standard, and it actually supports both the McKesson and Agfa systems. And so you can see up here, this is just a standard HTML-based application, so it would run on iPhone, iPad, Mac, PC, anything. And I can come in here, and this is hitting the McKesson server right now, but I also have the Agfa server, so I can actually query on last name, so WH-SAR, and we'll query on this return just that patient. And I can query on the patient ID or session number. So this application literally took me about 30 minutes to build, very, very quick, plus 4 hours of debugging, but 30 minutes to actually get to work. Debugging the back-end system, not mine. And then if I go to the Agfa server, you can see I have to filter it down properly. Like, was it 91? 9151. So that's a query against the Agfa server to actually pull up the study list. So this was kind of actually built independently. The second thing I want to show is the Cornerstone open source HL7 FHIR integrated with Keto RS and Watto to pull over the images. So in this case, you can see this is connected to the Agfa server. You see the one study there actually made a keto query for that patient, and when I click it, what it's going to do is open up the image viewer and pull down. It's going to make another keto query for the series, and then a keto query for the images. And it's actually pulling down the images directly from the Agfa system right now into the web viewer. And for those that want to know, I actually just started doing this integration about an hour and a half ago, so barely made this in the nick of time. So that's what I have.
Awesome.
Great.
Thank you. And then well, the next person is coming up. I just want to point out too is that while we're talking about this stuff, we can go out to the web and grab this and grab this. For those of you here who have some sense of privacy and security, these type of APIs have very strong, very proven models for enforcing authentication. So these things are not just open directories on the web that people can go and grab patient records. When these things are used in actual production, not in a hackathon with obviously de-identified data, these would be very much like online banking. There would be very strict protocols in terms of getting access to these servers and being able to execute the keto and getting the results back. And the technologies used are very similar to things like online banking and other industries that use web-type technologies. Paul?
I'm Paul Duncan from Agfa Healthcare, and before the hackathon, we spent lots of time building our Watto, Keto, and Stow APIs, and then when I got here, mostly I wanted to play with FHIR, because I hadn't played with that yet. So this is a patient list that I've pulled out of our FHIR server. Nothing fancy, but I can look at one of these patients. And so I've got a few panes here, the patient info and the orders and the reports are all coming from the FHIR server. I can look at one of these reports, say, pull up some text that was in the data. Close button hid. And the studies there, I'm just going to switch to another one here because it works better for me. The studies there are from a keto call, actually, to our server. So I can click on one of these studies, and it's going to open this little test app I built leading up to this thing, which is pulling down a bunch of XML data from the Watto server, actually. So this is doing a Watto call, and I can see that in XML. or in JSON. Whoop, that didn't work. In JSON, or I can even look at it. I can even download the JPEGs. If it's metadata, it gets the XML and JSON. If it's not metadata, it gets the image data. So just some quick ideas of sort of throwing these APIs together and seeing what I can come up with in a couple days.
Great. So I think we have one more to show. I want to emphasize something. The last one is that was an example of that test app of where we're just kind of, it's a developer tool to try and interrogate these APIs, see what they get back from them. The last one was really, you saw there was a number of different formats that his app could get the data back in, JSON, XML. These are different types of structured data or the actual image. These type of utility apps are very often used in hackathons by developers just to make sure that the API is working and that the data in it is what you expect back. So that last piece wasn't something that you would see in a clinical space, but this is the type of thing that's very useful for them to troubleshoot and understand how those work, and that leads to an actual full production development integration. But thanks for sharing that, it was great.
All right, so we got about a minute left. My name is Christopher Toll, and I work for Analytical Informatics and University of Maryland. And I'm one of the code hearers, so I got to help everybody out. And I felt bad no one got to see a broken app, so I figured I'd get one. So real quick, we have all this DICOM data, so we went ahead and queried it, but we had no way. The DICOM data that we had didn't match what was in the FHIR example set. So what I did, or tried to do, it got mostly with, I already put 90 minutes into this app. 100 minutes and we've been done. All right. So what I did was, you can see all the DICOM that came through, and I'm querying this through Keto. And if we cut and paste, this is weird on the other side. I can then come paste it, and I can paste it here, and I can send it out to the FHIR server. And this is the part where it blows up. So there you go, ladies and gentlemen. We do have errors. Thanks, everybody.
Right. Yeah. So we're going to wrap up. I know everybody's got to get to the closing session. I really want to thank, it's a fantastic crowd. I want to thank all the guys who came in here. As they said, a lot of them put in a lot of hours doing this, and I think it was a great learning event. And we also got a ton of great feedback from people who came through here, people who participated, our fantastic API suppliers and our sponsors in terms of how we can make this better. I think this is just the start of something really great in terms of a fantastic education and learning tool for all the SIIM members. So I'd like to thank you all and have a great closing session, and see you all next year.